called Prezi. This is a Prezi presentation. Prezi, not even our thing, but that's what it's called. So it's not PowerPoint, it's pretty neat. You'll see it paints you build this big picture, and what it does is you just populate into the next thing. It's really kind of cool. So they let me do this the first time, so it's kind of, yeah, of course. So let's talk about why we're here. Reduce signature, cyber, and electronic warfare attack surface nodes. So the idea is, in the electronic warfare age that we're in today, we're starting to use certain things that are collecting data, that are sending data, that is also being used to operate in a common operating picture, but also operate in the field of use for maybe even an attack vector or from fire's perspective. So the idea here is you now have more valuable assets in the field that you're looking to protect the data that's actually coming across. We're going to talk a little bit about that, but before we get there, I'm going to give you a little background on us. So about OWL, U.S. owned and operated. We're based out of Ridgefield, Connecticut. We have a U.S. supply chain, research and development. All the manufacturing is done in the New York, Connecticut location. So we're right outside the Beltway, not too far up in the Connecticut area. We do have an office in Alexandria, Virginia as well, which is the company that acquired us called DC Capital, which is a venture capital firm of ours. And we do all of our technical support and service in the United States in the location at Ridgefield. We're about 45 employees, and we're really self-funded, if you will, from perspective. In regards to revenue, I'll just throw this out there because we're private, but we do about $20 million a year in sales. So there's a couple different ways you do business with us, but from a perspective of our focus, everything has been cybersecurity focused for the past 17, really it's almost 18 years. We have about 2,000 plus deployments. I'm going to say that number is close to probably about 2,700 right now, depending on all parts of the Department of Defense, including the intelligence agencies. So we're talking NSA, FBI, all the three-letter agencies you can name. Also some of the labs, Idaho National Labs, Sandia National Labs, and that's where we actually originated, was actually out of Sandia. The idea around what our focus is really designed around what would be a cyber defense operation in regards to protecting the nodes and data applications that are out there, whether that be a file transfer or a full motion video capability and the such. So our global sales and service team kind of exists based out of Ridgefield, but we have people overseas. We have partnerships in different parts of the country and the world, depending on where you go. Now, the United States perspective from a DoD sales, I control the Army, Navy, and Marine sales operation in our realm. And what we do is we have a specific product we deem the cross-domain solution, which comes with a filtering technology from the NSA, in some cases, that can only be sold to the United States Department of Defense and the Five Eyes in certain exceptional cases. Other than that, we have a commercial product line that also does the same thing. We're going to talk about that in a little bit. Our configuration management services and accreditation comes as a part of a package that we could deliver to our customers. And the reason for that is because of accreditation based upon the cross-domain solution itself. So let's talk about the solutions. So there's two types. The government cross-domain solutions are really designed, like I said, DoD and the intelligence agencies. But the people that look at our product to certify it is the UCDSMO baseline. So we're on what is called the UCDSMO, which is Unified Cross-Domain Services Management Organization Certified Products List, which means if you're connecting to the networks like Nipper, Sipper, or JWICS, or any of the black networks, you're going to go to a list of certified products that you don't need to go through an accreditation for. That's what we have. So I have certain products that can do certain things, whether that be a UDP transfer for full motion video or a sensor data that might be coming from a node. That type of streaming traffic can actually be done. We also have a file transfer-based solution that's on there as well. So essentially, one-way transfer is really what we're looking for, but we'll get into that a little bit more when we talk about the cross-domain. Critical infrastructure really talks about our commercial product line. We service the utilities infrastructure, nuclear, electric, gas, and water, telecommunications, financial services, but we also do the oil and gas and petrochemical. One of our biggest customers is, because of Stuxnet and some other things that have taken place, one of our biggest customers is Saudi Aramco. So that's a huge thing to say, but not a big thing to share. The idea is they were trusting their firewall at first, and guess what? They can't do that no more. So now they're trusting us. So we're the ones that are actually protecting their network. When we talk about the nuclear power facilities in the United States, we're protecting over 50% of those that are based here. So the idea now is, okay, usually what you used to have in the 80s is the nuclear turbine could be turned on and off via VPN from a guy working from his house somewhere in his flip-flops and his jeans. And now you have an ability of you need to not have that happen. Department of Homeland Security has gotten involved in regarding to a NERC compliance perspective. NERC stands for Nuclear Energy Regulatory Compliance. And the idea here in that committee has really stood up to the fact of what do you need to do to protect your networks. That is where we come into play to protect what would be the details of the critical infrastructure marketplace itself. So those are our two product lines we focus on. And basically the technology really designs around a couple different things. We have about 28 different patents. We have a single 1U 19-inch rack mountable solution that contains our communication cards, but there's three ways really you could buy our stuff. The first way is a DIY approach. You could buy our communication cards, which we give you a blue and a red card, which is a source and a destination card, if you will, and a fiber optic cable with the software package in order to have the drivers to send a type of information. Or we can install those communication cards inside a server, whether it be an HP or Dell or any server that you want to have ruggedized to deliver that as an enterprise solution. Or we have our appliances that are actually a 1U 19-inch rack mountable solution we talked about earlier. So those types of things are all driven around one thing, the dual diode. That diode was a patented technology, was founded at Sandia National Labs actually, in coordination of an effort to say, how do we do a one-way transfer and protect the data point that's actually being shared between the two? That diode uses LED technology, which is on the end of our communication cards, which can be purchased to do it yourself or in our technology itself. And the idea is it uses asynchronous transfer mode to send from one side of the network to the other. It does not protect, it does not send any IP information, so it's protecting the value, the asset that's actually sending the data, so you can't pinpoint where it came from or doesn't have any IP information as being followed. We open up specific ports and kind of use it from that way. That engages what is called a deterministic one-way transfer of information. So in the prior presentation, they were talking about software, and the software actually allows you to protect, what's happening as a malware attack. This prevents any malware attacks going back to the source network. So whether it be a low to high configuration or high to low, that's the configuration that we're looking at. Our certifications go through also EAL certification. So we have EAL4 and EAL2 with our communication cards, depending on what you're looking at. And we have, again, the UCDSMO approved products list and NSA approvals. Now, the NSA piece really ties back into the UCDSMO. But the idea around the NSA approval really starts to talk about what type of encryption device might be in front or after our device. Or in some cases, we're in conversations, we're bringing both of those together. But the NSA approvals really goes back into the filtering technology that's enabled into our box. We have an accreditation based upon those filtering capabilities that we have engaged. So as we go through the presentation, we go back into now our markets again. And this kind of talks about the government agencies, Army, Air Force, Marines. We're talking about the intel agencies as well. So what are we doing? So there's certain use cases that we have, including collecting sensor data, transferring to a secret enclave. A good example would be a UAV takes a full motion video picture capture of somewhere in Afghanistan and needs to send it to a ground station. That's a great example of something. We want to protect the ground station and share that information. But more importantly, we need to share that with a coalition team. How do we get it to them? And how do you do that without having them having access to your network? Well, you use a cross-domain solution or a one-way transfer to do that. That's where we come into play. So both the low to high and the high to low transfer is there. We have the controls and the filter for content examination. So what that means is if there's a Word document need to be sent via an access file that you need to have forwarded, we can actually scrub out or exceed any executable details that are actually in part of that containment package. Anything that needs to be scrubbed out will not be sent across the diode. We can quarantine it on one side and you can look at the log files of why or who sent that information. We also have a blacklist, whitelist type capability as well. And the difference for the network security side of the house, or what we call the critical infrastructure market, we're really talking about the industrial control systems. Ironically, ICS, or what we call industrial control systems, really does rely on also the DoD market, right? Army has Army Corps of Engineers. We also work with the Navy in regards to the nuclear power facility that's on the submarines. So there's a lot of different ways of looking at ICS, but in the utility sector, energy, oil and gas, and telecommunications and such, we're transferring ICS data out of the plant for monitoring using the PI transfer, if you will, the historian database replication. We do that type of capability of sending a one-way transfer in or out of the detail, and we can do remote monitoring with no remote access to the system itself. So that kind of gives you the ability of an overview there. So going into electronic warfare, how does this matter to us? Well, we're here today because obviously TechNet Augusta. The idea here is we're in the Cyber Center of Excellence for the Army. The one thing that keeps everyone up at night is how they control the electronic warfare capabilities and not giving it to the enemy. More importantly, it's really controlling what type of collection, transfer, storage, and analysis of operational data that's critical to mission success. So when you talk about how to protect that information, it's practical use cases that we're looking at from a network architecture perspective of how to protect those networks and the critical situational intelligence that's being gathered. A lot of the stuff today is like, well, it's going to go to this network and we're good. It's going to be on NIPR or SIPR, and we're going to send it up to JWICS and it'll be fine. Don't worry about all that. But then how do you go from JWICS back down to SIPR, and how do you send that type of information? That's where we come into play to kind of help that type of passing of information. So multiple sensors, which seem to be growing. Everything seems to have a sensor these days, including the handheld UAVs, things to that nature, but the data collection points are growing as well. The secure communication between and across those platforms, between each of those networks, and classified network scenarios, we are protecting that type of database. So that's the type of information that we're trying to, in today's theater, generate and collect it from a number of endpoints, protect the endpoints themselves and what they're actually accomplishing. So securing the transfer, collection, analysis, tactical hardened cyber defenses, we have some in our booth, which is number 815 downstairs. Range of capabilities, field to centralized command, if you will, and I'm going to give you real life examples of some of these things. Protecting your sensors from external threats and attacks while getting data analysis through decision makers. So let's talk about the use cases. Typical use case, this kind of goes into an overview of everything. I have 4 of them here. But this is going to kind of put in a tactical ground station type capability where we start, and then we're kind of grow towards the enterprise solution where we can actually develop another communication path here. So let's talk about use case 1. UAVs deployed, ISR collection, forward operating soldier is looking to collect certain data points in order before a mission is actually going to be performed, executed, or finished. Let's leave it at that. Secure communications with local sensors. So that UAV needs to communicate down to a ground station, right? They have a SATCOM system, they have an encryption device. Well, how are they protecting that data, and how do they not give up where they are to the bad guys? That's really what we're trying to do. We're not trying to prevent anything as a compromise of where the soldier team is. And what we could do is protect the formats, including full motion video, UDP sensor data, and even live streaming of even files if that needs to come across. Ideally, you have different use cases that then share that information up to a satellite. Again, another use for a CDS, or what would be a controlled interface in this case. Tactical prevents compromise of the asset itself, where it came from. You don't want the bad guy to know. Another example of this would be if a doctor needs to do a tracheotomy in the field and someone's down in the field of operation and you want to send a helicopter to go get them, the last thing you want to do is tell the bad guys where the helicopter's going. Kind of interesting to think about the concept of technology is they have an iPad, they could do a tracheotomy right by listening to the doctor that's back in the command center, but you're giving up your IP of where you are. They could do latitude, longitude of where you're going to be located, and all of a sudden they can take 4 guys down instead of just 1. So the idea of protecting that data point is really an important asset. You don't realize the more technology we have, the worse this gets. So this is kind of just going through different ones. Use case number 3, satellite asset communicating with the command center. It's going back down. Live streaming video is related to analysts. The asset is protected by a hardware-based CDS from remote threats and capabilities, and the hardware solution guarantees it can't be breached. The idea in a one-way transfer is our communication cards can only go in one direction. If you need a bidirectional capability, you need to use 2 of our solutions to make that happen. You can't change the channelization of our cards. You can't change the operation. They're internal to our equipment as well. But there's nothing that can be manipulated in order for that to take place. So that's a true hardware-enforced one-way transfer of information. And here you go to the last use case, which is the command center sending communications to multiple endpoints for their common operating picture. Simultaneous transfer of different data streams and data types, full motion video, still images, radar detection information, metadata tagging that's on a radar sensor. Let's say you send the Predator UAV up. The last thing you want to do is show that the Predator is actually across enemy lines. You don't want to show that it's actually there, but you want to redact that information, but you want to show them, hey, trust us, we know the bad guy's over there. We have to figure out a way to how to protect that. We have enterprise class CDS protecting real-time transmission, supporting high bandwidth requirements. Everything we sell goes by throughput. So some of the tactical solutions start at 10 megabits per second throughput, can go to 26 megabits, but we can go as high as 10 gigabits per second in the enterprise solution. So we have a lot of scalability, and most of our solutions are software upgradable in regards to in the field transmission. If you buy something, you can grow with that type of equipment. You never have to replace it or grow out of it moving forward. So there's a lot of valuable ability in regards to the purchasing detail. Interface and protocols, you know, coalition. Yeah. Absolutely.
So I just want to clarify. So you're talking about obscuring or obfuscating like the ground tactical unit location. But you're talking about like protocol obfuscation, not RF obfuscation.
That's right.
RF signature for the control channel from that tactical unit to the gas.
That's right. Yep, we're talking about what exactly is streaming data or information that's being shared from it. Yep. So that is how we protect that information, and really we're going to talk about those protocols, but this really talks about all the different types of protocols that can be sent. Not all of these apply to the electronic warfare side, but coalition information sharing, UDP, multicast, broadcast, unicast format, data transfer and video. We have TCP, file, and syslog. Those are capabilities we can be done. Obviously, you're not going to do syslog in a tactical environment, but we have that in our enterprise solution. File transfer, FTP, secure FTP, email, Modbus, OPC is sort of on the industrial control side. We have remote file transfer, alarms, SQL databases, SNMP traps, things of that nature. So we provide the full gamut of capabilities. It's a matter of what type of system do you need or what do you need to utilize to make that happen. So our solutions talk about the secure one-way only design. High to low, low to high transfer, doesn't matter. Either way, we have certified products that are already on the UCDSMO validated products list. They're modular for your ease of certification and use. The range of solutions go from the server-based card systems, which you could buy, the DIY approach, the communication cards, or you could look at the low size, weight, and power, the swap solutions, which kind of give you the 1U interface, which goes anywhere from 26 megabits all the way up to 1 gig, or the 2 server configuration, which can go anywhere from 26 megabits per second to 10 gigs per second throughput. So we sell our products based upon the throughput that's required of the mission. So this is very mission specific in regards to what's there. Miniaturized and portable solutions for tactical and remote deployments. We're actually talking about and developing right now different systems that are actually going to be deployable to be placed in different aircraft, submarines, things in a tactical environment that would be a tactical appliance that has a 37-pin connector, things of that nature that are kind of different than just an Ethernet connection or just a fiber connection to make that happen. So these all-in-one systems are, like I said, 19-inch 1U systems that are actually designed where you have an inlet in and an outlet. These are usually Cat5 or Cat6e cables coming into the back of the box and out to the other side. You also have this capability in a fiber connection, but you can't see anything else. Everything is contained inside. Nothing can be changed. It's a locked system. The cables are locked internally. Everything has a locking mechanism because this is an NSA type approval. So we've gone through those ramifications of the small form factor box itself. We also have what would be different options for that, whether it be the ST06, which is for streaming video. We have the NSA filter set that's a part of the metadata tagging that's actually a part of the codecs for the video. That's a part of the filter set that you get with that OCDS ST06, which is on the baseline that way. The FT15 really talks about files and image transfer. So there's different, you'll see the Navy DSOG did the approval for the ST06. The DIA did the approval for Air Force. We recently did another approval for packet transfer and another system called the OCDS FT15, which is new to the list as well. So all of these carry forward for systems. So the communication cards are really those blue and red cards there. You could purchase them with a fiber optic cable, kind of move those and the operating software to go with them. Or we can put them through what would be installed into a Dell or HP server. So then you have one card in one in the other. They're connected via fiber optic cable and kind of go from there. And this is the system that we actually sold to DISA originally and is a file transfer for high volume transfer. So we were doing sort of the DISA deck was looking at this as a high bulk file transfer. We were doing 50,000 files a second, So there's some huge data transport being done here in regards to our systems that were there as well. So that's just a bunch of different options that you have. Realistically, what we deliver as combat operations rely on, different details. So when you expand these sensors, you need to protect them. How do we protect them? Well, we have controlled interfaces and cross-domain solutions. Like I said, there's two different worlds here. There's this world that what is a cross-domain solution and how much is it going to cost? Well, what we provide is a fixed fee cost for the hardware and an annual technical support option, which is something that the customer can budget for going forward. Very simple to use. In lieu of a statement of work and conceptual design and draining out what the software engineering side of the house needs to do. This is a set it and forget it type application that does not need to be updated as much. So the combat operations rely on the number of sensors and real-time data sharing. Certified diode-based cross-domain solutions provide the DoD with rapid deployment. And our solutions are hardware-enforced one-way transfers that provide the best-in-class solution for electronic warfare scenarios. More secure than a firewall. Gartner has a paper out that says, firewalls used to be what everyone trusts, and higher than a firewall is a diode. We have the diode engaged in our hardware, so that's kind of where we fall forward. Working in a variety of scenarios and protocols and data types, we can address all those different industries and areas that are needed in the world we live in today. And that's all I have.
So you talk about cross-domain. You guys are accredited for TS?
Yes. So we have both SABI and TSABI accreditations already on our approval list.
And does this appliance go from sort of the black to red scenario, or do I need one cross-domain for each security domain in my product?
It's okay. We have a jump that goes from NIPR to JWICS, and we have one that goes JWICS to SIPR. We also have some black network connections that go down to SIPR as well. So we've done a gambit of ones. It depends on the accreditation authority of who's actually involved in that. That's going to be the deciding factor of who goes where and how it gets connected.
So is your tactical solution just essentially a ruggedization of the blue and red card?
Yeah, so we've miniaturized the blue and red card to actually matchbook size, if you will. I have an example of that with a screen downstairs at our booth. And basically we have I'm going to call it half of a cigar box, but there's an Ethernet connection on both sides, but you can use that as an application. We're using that right now in the nuclear power facilities as DIN rail connection. And the DIN rail is really just this rail that's on the side of the wall and they connect the two. But the militarized piece of that we're going to do is use the inside of that, but import the filter set from the accredited solutions in order to give it a smaller footprint for the customers to use, whether it be in the bird or in a submarine or on a boat or in a tactical vehicle, if you will, and or carry around in a briefcase to be deployed, in an offsetting type detail.
Literally, it's just Ethernet in, Ethernet out, power.
And power, right. But the tactical box is going to change. That's going to be like a serial type connection with a locked in 37 pin connector to do the transfer of data, depending on if it needs to be serial or whatever the other connections may be in the world that we're living in today. So we're adapting to that type of element. We have the box downstairs to show, but the conceptual design of what will be the next feature of that box, that's something that's still in development right now. We're working on a couple RFIs that we're responding to as a direct result of some of the size, weight, and power requirements that are there. So we're hoping to kind of build it around what that would be.
And you currently have an appliance, but it's just a one appliance?
Yes, yeah, absolutely. The appliances we have right now, the smallest in the CDS world, are really the 19-inch 1U rack mountable appliance. And in most cases now we're talking about we can't use that in a bird or something to that nature. So we got to figure out a way to shrink that. And we're talking a 3 by 4 inch type spot. That's going to be kind of how big it'll be in that world that we live in today.
The one you have today, out of curiosity, how long have you had it?
The 1U box. We've been around for 18 years. That's been around for at least 13 years, I think we're going on right now. So it's been a while, yeah. A lot of deployments, yeah. So we've been around, we originally started with the communication cards, and once the communication cards kind of kicked off, the intel agencies really buy those to develop their own, what they call a cross-domain solution, but they want to install it into their own servers, create their own filtering capability. The Army, the Navy, the Air Force, they really want all-in-one solutions that are already done, so we don't have to go through that. We have that solution. That's where 12 years ago, about 13 years now, we go back, that's where we started creating what those appliances would be, and now we're building to the next level of shrinking them to a very small capability.
What about doing a custom protocol?
If we have a custom protocol, it's not on our list that we've already seen. There's a 25K flat fee tailored variant that we would do to change that. What we would do is first take a tailored variant of something that's on the baseline already, whether it be a file transfer or some other protocol that's not there, and then we would create it from there. We're familiar with it. UDP. What we care about is that we don't care about if it's link 16 or whatever other type of data might be there. What we care about is the raw packet. Is it UDP? Is it TCP? Is it file transfer? That's what matters to us. We don't care about what format that it's actually in or what it needs to be transferred in. We'll make sure that it rebuilds. The way the communication cards work is you're sending a send and a receive optic, and what we're doing is rebuilding all the packets that are on one side. It's using asynchronous transfer mode to send it from one fiber, the LED that sends it, the one that receives it, and it rebuilds it onto the other side the same exact way. So there's no packet loss or anything else that's there, unless there's a filter that needs to drop something that doesn't need to be in the interface. Yeah, so on average, about 8 milliseconds in regards to latency. If you induce some of the file transfer type filtering capabilities, we go as high as 20 milliseconds. So we're still in a range between 8 to 20 milliseconds, depending on what you're looking for. In regards to UDP streaming video or anything like that, I mean, you're looking at, I've seen it as low as 4 milliseconds. So it depends on what's being filtered. Yes. And the filter that we have currently was really directed by Boyd Fletcher. I'll leave that as itself for the NSA. It kind of guides the guidance of what needs to be looked at, what needs to be sent across the diode. But those filters are all designed around that type of capability that we're working with him directly. So it sounds like you guys have a use case. Avitech Pacific. Right.
The other one required administrative support that the customer.
Right. So we battle against, in the world that we live in, we call them our frenemies, but TAC CDS was just acquired by General Dynamics, but Radiant Mercury, High Speed Guard, those are companies, Lockheed Martin, Raytheon, those are companies that typically you'll see that against, and they have a software-based capability which needs a lot of administration work in order to make that work. This is more of a set it and forget it, plug and play type operation. And most customers, go down that path. Once they start talking about the statement of work that needs to be done in order to deploy that, then they come back to us and say, oh, wait a second, one-time charge for the hardware, nothing else to be done. And that's an advantage that we have from the budgetary process itself.
So for the appliances, there could be just an acquisition cost and there's no follow-up.
Yeah, there's a one-time fee. Even the communication cards is a one-time fee for the hardware. We can provide you the software with that. And then there's an annual technical support option for what you need to do to cover it. And that's a flat fee that might go up 5% every year. But at this point, it's really a flat fee that you can budget out for the rest of the eternity that it has. I will tell you that most of our equipment, including our 1U appliances, have been deployed, have not come back. They've been deployed for 12, 13 years. We haven't seen anything come back as failure. But one of the things that we put up front is our sort of insurance policy. If anything goes wrong on the DoD side, we'll immediately replace that product. We've never had that problem at all.
In the appliance, is it all solid state?
Yes. Yes. Yep. And you can see the inside. I have a picture downstairs in our booth. We have a picture of what the inside of the appliance looks like with our stacked and secured Linux operating policy and CPU on each side of the appliance. The air gap is essentially the fiber optic cable, but internal to the appliance, we have a separate hard drive and power supply. That's an SSD hard drive that's there. It's an 80 gig. So we could take off the log files for something that might be quarantined or taking anything else that needs to be quarantined before it gets sent to the red side. And vice versa on the other side, we can also quarantine it once it lands as well. So that's a part of the mechanism that's actually integrated into the system.
How difficult is it to set up the filters that you talked about? I mean, are you down to kind of keyword blacklist, whitelist level? Or are you talking more of the
Yes. So we have role-based access controls that gives the admin the ability to manipulate what that is. As soon as you configure the system, which takes on average about 20 minutes to get up and running. Once you have that up and running and we put it into, there's maintenance mode and operational mode. Once you put it into operational mode and you set it from maintenance mode of what filter set you need to do, it's done. You're good. Nothing to change from that point forward. Now, if your mission changes the type of files that are being sent, for example, we have a box called the OCDS FT15 that comes with a menu option of 71 different file types that could be sent from the blue side to the red. You can restrict every single file type if you wanted to, besides 2, and say, I only want these 2 to come through. Anything else that comes through that's not in this file extension type, quarantine it, never send it across. Everything that does come through, we can do packet examination of every one of those file types before it goes across. So you set that in the menu, you say on or off for whatever menu item that you actually want or file type that you want to have come through the diode. So there's certain ways of making it very simple. This isn't let's say you have a different file type, LDF type file and something like that with an extension called LDF. And then later on the line you want to go to an MDF file. We have the ability of not having to take the system down. You put it into maintenance mode. You actually pull it up the menu item. You change it to the MDF to accept that format and put it back up into operational mode, and you're up and running again, and no big deal. So it's not we need an engineer, let's talk to 1-800 number, let's figure it out. We give you the power to make that happen. Now, the thing that you cannot change, because it's a lockdown system, you can't change the way it actually sends the information across. You can't open a different port to make that change of how it comes across. We are actually, since it does not channelize or give any IP information of the source network that it came from, what we're doing is opening up specific ports and only making the system listen to those specific ports. If a bad guy sends it from a different location to a different port, then it will never come through the system. We'll deny it and won't have that access to that port number as well. So we pre-design it that way on purpose. It's part of our secret sauce. You guys ready to buy? Absolutely. Well, thank you for coming and joining the presentation. Let's see, I think I have, yeah, awesome. Yeah, we're right down on the wall, all the way down on the right-hand side. So where are you guys based out of?
I'm in New Jersey.
Oh, okay. San Antonio. So in San Antonio, we have a system out in at the DISA deck, the Joint Regional Security Stack, that we worked with. And safe. Are you guys staying to Friday, or are you guys out of here tonight? Yeah, I'm staying for that CyberQuest Information Day thing that's going on Friday. So that we needed to control, so they decided not to do that. But this year, I think it's finally maturing to the level I think we want to get to. So we'll see. They're trying. You know, the idea, the Army doesn't spend a lot of money, let's be honest. So where do they go from here kind of thing is what matters, but they got to figure out how to spend money the right way. And I don't know that they're ready to do that yet. But in order to play in the game, we have that new capital solution that we're building. You know, this is a great test environment for us to get that into play. And for them to test out what connection points it needs, how's it going to get powered up, what's it going to do. So we're interested in that perspective to give it a market that we want to issue. Yeah, so that's really what we're looking at, and now we're willing to do the investment into that. So we went from a privately owned engineer that was a prior IBM guy that kind of created our company to now we're owned by a venture capital firm. So now we got a little bit more money to say, yeah, we can take that risk. Let's do these kind of things. Where before he was like, yeah, they ain't gonna buy it. We're not doing it. I'm not building it. I've been here for 5 years,